Okay, all right, now I'm on. Great. Well, good morning again. I had just 60 seconds earlier to speak to you, but I'm very delighted and happy to be here. I represent a team from the University of Michigan led by Dr. Charles Friedman. We call him Chuck, and Chuck has been here as well, and so he certainly sends his regards on behalf of our department, in regards to all of you, and thank you. And thanks everyone for coming today to hear all of these fantastic talks, and I hope mine will rank with them today as we talk about the work that we're doing to support infrastructure for a learning health system. As Dr. Stein said, I'm a pharmacist, but really today my talk is about information science, what used to be called library science. But now we call this information science, and it's about organizing information. So the previous talk was a lot about the drugs and what we can learn about drugs for pharmacogenomics in order to improve patient care. My talk will be picking up on what Mark said, how do we update a system with new knowledge over time? So that was on his slide. It's a perfect setup for the talk that I have to give today. So we are working on a thing that we call the knowledge grid, and I'll talk about that in the latter part of my talk and tell you what that is. And I'm going to introduce this concept of activating knowledge today. I'm going to make the assumption, because it's a generally known fact in information science, that people who get to work with other really smart people prefer to ask questions and get a quick answer from a very knowledgeable person who has a very good memory. So when we are practicing in the hospital, in the pharmacy, it's great when you have a colleague there who you can go and you can say, hey Mark, what was that star 5 for CYP2D6 again? Right? And he'll say, oh, that means a slow metabolizer, so you should do this. Great, that's great. Challenge that we have, though, and this will be the part of my talk today, the challenge that we have is that here is Mark, but we can't put him everywhere where that question comes up to give us that answer, even though that would be great if we could. And so what else are we going to do? This is the problem. Okay, so here's my agenda. I wanted to cover these points. I think there are 6 of them, if I counted correctly. So we're going to talk about knowledge organization. I'll just point out a major change over time in the way we're organizing knowledge, and you're going to see how we're making use of that in the work that we're doing. And then I need to define something. I need to define, when I say what is actionable, computer processable knowledge, we need to define that, so I will. And then we'll discuss this idea of knowledge activation. When we get through with that, we get to the second part, we're going to talk about something called knowledge fairness. But we need the first part in order to kind of understand what that concept is all about. Then we'll get to the knowledge grid, which is actual software system that's being built in our lab. And finally, I will give a brief update on the work that we're doing in the international collaboration project that was mentioned earlier. So this will be the agenda for this period. Okay, so the first of the 6 items is the science of knowledge organization is changing. So the students that I have now at the University of Michigan, many of them may never have seen a card catalog in the library. But right, if you think about it, because the card catalogs are now going away. But it used to be, we would go to the library and you wanted to find something and you went to the card catalog, and in the library that we had these drawers here, and you went through and you found the things organized that way. And over time, we've had this thing called the internet, and now we have PubMed, and we have Google Scholar, and we have electronic ways now, and we can look up documents in electronic form, all of this biomedical science that we need to learn from in a learning health system. Nevertheless, even though we've gone from something on paper to something electronic, in the digital library community, this is still thought of as the document orientation or the document view. The documents have gone from paper into electronic form in many cases, but we're still thinking about managing documents in a particular way in library science and information science. But there's something that's changing, and that is, once we have this electronic repositories of our biomedical science in written form, a paper with its citations and so on, now we start to have a database that we can analyze, and so we have the science of bibliometrics that grows out of that, okay? Analyzing how papers in science are interconnected through their citation patterns. And that brings us to a very different view of biomedical knowledge. Instead of document by document, now we start thinking about a graph or a network. And we start seeing how the biomedical knowledge that we have is interconnected in a bigger system, a bigger network type of system. Because we take a paper like this and we say, okay, but this paper references these 2 papers, and these papers reference 20 other papers. And so people are now mapping those references, counting them, thinking about them. Meanwhile, also coming along is this technology of the semantic web, right? An internet that actually has some embedded understanding of content. So it's not just the content is there, but the actual computer systems can process that content in a more effective way. So you may have noticed over the past several years, I believe starting in 2012, if you use Google or some other major search engine, you may have noticed that now when you type in, like I did the other night, one word, type hey, I get a whole bunch of related information, not just links, but I get a map, and I get a nice little paragraph, and it tells me what the weather is going to be, all of that, and I didn't have to do anything, I just get that response. But behind the scenes, the knowledge that we have had to be reorganized in order to do this. This is a question of knowledge organization. So if you remember, just a few years ago, a search engine like this, you put in your keyword search, you just got a list of links for web pages. But now, you get a picture, and you get a bunch of related information. In a learning health system, these effects of bringing information together in new and more powerful ways on demand, this is what we want to achieve, I think, in order to get to the point where we can do what Mark was saying, which is be able to tell a person in an effective way right on the screen what they need to know that's related to lots of other things. So we're watching this transition from the past at the top to the future, and we've gone from a document view of how to organize our knowledge to a graph or a network view. And the work that we're doing in the knowledge grid is to take advantage of this transition where we cross this line. All right, so in a learning health system, we are operating as empiricists. We gather data, we put that data through some analytic process, and we generate some analytic result. This is a starting point, in a way, of thinking about what we need to do. It's obviously a high-level abstraction. I didn't tell you what the data were about. I didn't tell you what the analytic process is. I didn't tell you what the analytic result means. But just staying at that high level of abstraction, this is a general process that we're all very familiar with. And in a learning health system, we'll have this process going on in myriad ways. So, we need a definition of knowledge in order to progress this talk about the knowledge grid. And so here's our definition of knowledge. Our definition is that knowledge is an analytic result that is meaningful to someone. Okay, so again, we're empiricists here. We're thinking about you analyze a data set, somehow you get a result. And if that result is meaningful, meaning that it complies with some semantics of someone, that someone can understand this result and explain it, we call that knowledge. Okay? So in biomedicine, of course, when you generate new knowledge in the laboratory from studies, you want to get that published. All right? That's the very same thing that I'm pointing to. I'm pointing to what we're all used to. I want to call that knowledge that's based out of some empiric process. All right? So that's what we think about as knowledge. If I didn't have this slide, people will often ask, what do you mean by knowledge? Okay? So this is what we mean. We mean an analytic result that is meaningful. Well, knowledge is a great thing, but not all knowledge provides the same benefits. And so what we're thinking about for a learning health system oftentimes is actionable knowledge. You've heard that term already today. So this is a new property that we want to add. We want to think about how do we go from just having knowledge, the result of some analysis, to having actionable knowledge. Well, the property, the way we define it, is that to be actionable, the knowledge has to have some potential to inform one or more decisions. All right? If it's actionable knowledge, it has the potential to inform one or more decisions. Not all knowledge necessarily has that characteristic. But actionable knowledge, by definition, the way we think of things, has that characteristic. Okay? It can inform a decision. So actionable knowledge is some analytic result. It's both meaningful and it has the potential to inform a decision. Okay, this is what we're very interested in the knowledge grid. Well, we're not done yet. Expanding this definition another step, we have the data, we have an analytic process, we have a meaningful analytic result that has the potential to inform decisions. This is the actionable knowledge. Now, the work that we're doing in our lab is to say, okay, a learning health system is going to generate enormous quantities, potentially, of actionable knowledge. How do we then encode that knowledge and make it also computer processable? How do we make it so the computer can understand and process that knowledge in an effective way? Okay? This is the challenge. And this challenge is not a new challenge. Okay? So knowledge representation so the computer can apply the knowledge automatically has been around for many decades now. But we want to do this at scale for a learning health system. And we think it's absolutely necessary for the system to be effective. Because again, Mark, smart as you are, but just don't scale internationally around the globe. And he was telling me earlier today that he was skiing in the mountains and he was getting paid to give an answer because he's the expert. So I want him to be able to have a nice ski vacation. So we need to get the knowledge out of his mind and we've got to get it into a way that makes it transferable. And that's what this is about. So actionable knowledge becomes computer processable when we encode it. We put it through some process and encode it. And that it supports some level of automated decision making. Okay? It doesn't mean that the knowledge would necessarily make the decision and that the human being goes out of the loop. So when I say a level of decision making, it can inform a decision, make a recommendation, give a list of alternatives. All of these types of things bring some automation to the decision making process. This is what we're going for. All right, now let me make this very concrete as I can. Instead of talking in the high-level abstract with no concrete example, here's a real example. Imagine you have a data set, imagine you have a data set about lung cancer. We do an analytic process, you run a linear regression, okay? Just like these researchers did, and they published this paper in 2013 about lung cancer. It's a predictive model for lung cancer. All right, it's a 6-year time horizon predictive model. And what it tells the person when you read this paper, 2013 New England Journal of Medicine, here's the PDF. You get this table and it says if you know these characteristics, these variables about a person, and you know these coefficients, and you read this little tiny text here with a pencil and a pad, you can calculate someone's 6-year risk of lung cancer. Now, this is actionable knowledge because we want to use this risk score to determine who should be offered lung cancer screening, which is a procedure, an intervention, has costs, has some risks. So we want to know, well, who should really be offered lung cancer screening for people that are at very, very low risk of lung cancer. It's not a good use of the screening. This model will help us figure that out. And so we're very interested in this. But as you can imagine, in clinical practice, so long as we leave the table in the journal, it doesn't get used in clinical practice. Okay? I don't know how it is here. I can only represent what I know from Ann Arbor, but in Ann Arbor, we do not have clinicians who carry around tables like this and calculate these things. We just don't do it that way, because that's not how practice works. I imagine it doesn't work that way anywhere. It takes too long. All right? So we're going to take something like this. We can encode it, though, and we can write code, and we can make it computer processable. We can make the computer automatically calculate these risk scores. That's what I mean by computer processable actionable knowledge. Okay? In a learning health system, our belief is that we need an enormous, enormous corpus amount of computer processable, actionable knowledge in order for the system to work. Essentially, the memory of a learning health system, right, needs to be built. And we believe this will be part of that memory. So this is a concrete example. This is an example that we've actually encoded already, and we have, of course, the code running. All right, so you can think of this encoding process, taking some analytic result that's actionable, taking some publication that's already in the biomedical literature, putting it through this encoding process. One way to think about this is that we're making the knowledge more active, we're activating it. Okay, so the knowledge is latent, sitting here in written form. It's waiting to be read and applied and acted on by people. Okay? But the problem is, and we're seeing this in pharmacogenomics and other areas as well, there's so much knowledge, waiting for people to read it and apply it all in practice is not going to be effective. So we argue we need a way to activate it, make it computer processable so it can automatically be applied, just the way that we were talking about decision support before. Okay? And if we can do that, and if we can do it at scale, we believe we'll be able to begin to support the vision of a learning health system. So a high-functioning, that's Dr. Friedman's term, a high-functioning learning health system, one that's working really well, depends, we believe, on this actionable, computer processable knowledge. The learning health system requires something called patient-centered cognitive support. This is Dr. William Stead's concept from Vanderbilt, also part of the Institute of Medicine write-up about a learning health system, which says that today in most electronic health record systems we do not present the biomedical knowledge that we have in a way that makes it most relevant to clinicians who think about the human body in a particular way. And so we should be presenting the knowledge that we have in a much more visual way, in the way that to match the mental models that clinicians have, but we generally don't yet do that. That's patient-centered cognitive support. It should make it easier for clinicians to practice, but we just don't do much of it yet. We believe that individualized, tailored messaging is very important. So the idea that in pharmacogenomics that a single message is going to work for all stakeholders is probably a fallacy. If the message is intended to support shared decision-making with the patient, then it probably needs to be a message that you can read to the patient and they can understand. If the message is intended to drive a prescription decision by the clinician, then as you showed, it needs to be written in a particular way that is understanding of that workflow and that result. So the same knowledge will ultimately need to be tailored and individualized to different cases. And that's hard to do today. We need easier localization of general guidelines. Okay? One of the complaints about guidelines that's very valid is that they just don't always hold up under certain local conditions. All right? It doesn't mean the knowledge in the guideline is no good. It just means that we also have to add in some of that local information to make the guideline effective under different circumstances. Capabilities to quickly combine knowledge is another thing that's difficult to do today, but we think in a learning health system this is going to be absolutely necessary. So for example, to combine a predictive model and the output from a predictive model with a set of rules in order to get to more effective information interventions. So all of these types of things, tailoring of messages automatically, combining knowledge, localization, this kind of patient-centered cognitive support, these are not things that we can provide without the computer. These are not things that we can provide manually. And this is driving our work. We're also concerned as we move from the document world of written knowledge to computer processable, actionable knowledge. We're concerned, and I put this in Dr. Friedman's voice here, because he's asking this question of all of us, what is the future of open knowledge? As our knowledge gets encoded in computer processable forms, many times in algorithms or other forms the computer can automatically work with, will the knowledge that we have remain as widely available as it is today in written form? Okay. So we're concerned that policy support for a learning health system needs to help us make sure that we continue to have good access to biomedical knowledge in a learning health system. access that I can tell you from my practice, I tend to take for granted in a large health system, that I can get to the journals and the papers that I need to get to in order to drive clinical decisions. So we're paying attention to this as well. All right, I mentioned that we're looking at networks and graph models of interconnected knowledge. And there's a concept that we're going to take right from data science, and we want to apply it in knowledge organization and knowledge science. And it's this concept of what they call fairness. All right, so for an online network of computer processable knowledge, if we have a network, it can help us make that knowledge fair. What do we mean by fair? The first thing is findable. Okay? We have to support good search and discovery of this kind of knowledge. Just like today we can find a paper from 20, 30 years ago. If you just tell me the authors and the journal, I'm sure I can find it. Okay? Well, a few years from now, if you tell me the creator of an algorithm and where they created it, I should also be able to find that. Okay? So metadata for search and discovery make it findable. Accessibility is a key point. So this kind of knowledge in this form, computer processable actionable knowledge, needs to be uniquely identifiable. And again, we're concerned about openness, and part of the openness story to make things accessible are protocols that allow systems to access this knowledge. But we have more work to do. In the informatics community, we're very interested in the science of interoperability. We need common languages and terminologies applied to this type of computer processable, actionable knowledge in order to facilitate interoperability across different systems and uses. And then finally, we'll know we're getting somewhere when knowledge in this form starts to become reusable, where we can understand its provenance and its origin in a way that we can trust the knowledge, where the knowledge that we have in this computer processable form carries licenses and other policy support that make it useful in the world. All of these things need to come together. We didn't come up with these principles. In 2011, a group got together and they were focused on data sharing, but we believe these principles are just as relevant for knowledge sharing. So we have these FAIR principles. All right, you may have seen a slide like this before. This is our classic kind of learning health system slide from knowledge to practice. And so the way we think of things, you have a group in biomedicine interested in a problem, like the problem of how do we determine on a genetic basis which drugs to prescribe for which individuals. We're going to assemble relevant data. In the case of pharmacogenomics, we're going to analyze those data, we're going to generate some results, and we're going to learn. We're going to learn about enzyme, drug, genome relations. And oftentimes we're going to publish articles, and this is what happens. If you look at the CPIC guidelines, you see the articles there, which we desperately need to support, to give us the evidence base, right? So we publish the articles, and then we're hoping that people will read and react to those articles. Okay? Or we publish guidelines, and we're hoping that people will read and react to those guidelines. Just as Mark showed, you see this exponential increase in our overall global capacity to generate new biomedical knowledge. And so in the United States context, in indexing and Medline, we're getting close to 1 million new articles indexed in a single calendar year. That's a lot of biomedical science, and the learning health system needs to figure out better mechanisms to find what's actionable and useful in that corpus and apply it. This is the current state. We believe that a network system of activated knowledge is going to be necessary. That is to say that a learning health system won't be able to function effectively without it. We believe that once lessons are learned, a new type of system is needed to move knowledge through the system into practice. And so this is what we're working on. We are working on infrastructure so that once we learn something from our capacity to do the biomedical science, we can then encode that, make it activated, put it in a network of knowledge like that, connect it to other knowledge, and then use it to inform decisions in practice. This is what we're working on. So now you know what the knowledge grid is. The knowledge grid is a piece of infrastructure that fits right here in the learning health system cycle. And I want to emphasize something very important. Our work is not an infrastructure to support the whole cycle. We're focused on a major challenge here, which is to build out a knowledge organization and knowledge management capability that we think is needed by a learning health system. Okay, but the analytic capabilities, which are profound, need to continue to grow and get better, and ultimately be connected to what we're doing. And then existing health IT, which we've already talked about a lot today, EHRs, health information systems, hospital systems, and so on, also need to somehow connect to this knowledge grid. So the knowledge grid is just one piece, okay? But we think it's a critical one. So the idea of the knowledge grid is to greatly speed up delivery of knowledge into practice. It's intended to help answer the question, how are we going to update the corpus of pharmacogenomic knowledge effectively on national and international scale? Okay? Which is a question that was raised, in Mark's presentation. So we think it's absolutely critical that the knowledge is in a computable form. I mentioned that already. We have to activate it. Then we think it's also going to be critical to have new types of digital library platforms to store, manage, and make this knowledge findable, accessible, interoperable, reusable. Within those systems, we need lots of mechanisms to protect this code, essentially, and make sure that people can trust it. Okay? So today, if you think about it, why does a person trust or not trust a journal article? Because you can look at the methods that were used, because you can compare it to other articles that were going after a similar question, because you understand something about the scientists who performed that work, because you understand something about the peer review that went through when it went into a particular journal. All of these things are in the back of our mind when we evaluate today a study. You also understand who paid for it. And I'm sure you were taught this, as I was taught in pharmacy, that if it was paid for by the pharmaceutical industry, you might want to double check with another study, things like that, right? So trust is a big, big issue, and we need a system that can help us also trust this knowledge in this new form. And then we're not done yet. And this is work that we were working on just this week here in Taipei. And this is the work of connecting knowledge to practice. So just having a digital library of computer processable knowledge for biomedicine is not sufficient. We need ways to connect that to existing systems. And we've built something that we call an activator, which takes the knowledge out of the library and puts it to use. And then finally, we build interfaces to existing systems, EHRs and health IT. So when we do all of these things, these 1, 2, 3, 4, all together we call that the knowledge grid. Those are the main capabilities. All right, so we start with the knowledge object. So in the knowledge grid, we have a concept of a knowledge object. What is it? We take knowledge that already exists in the world, some guideline, some paper, some analytic result. We put it in a computer processable form. We think of that as the payload or the core of the object. We add interface information. We tell the computer, how do you interact with this object? Okay? What data does the object need in order to generate a result, and what result will it generate? But, as I said before, we also need to describe much more about the object. Who created it, when they created it, why they created it, what data is it predicated on? All of these types of facts about the object fit in its description. We believe if you put those three things together, we have this model of a knowledge object. We believe that this is now a manageable unit, like a book, in a digital library of computer processable actionable knowledge. Okay? It's a manageable unit. And you can imagine all sorts of different payloads for knowledge objects. And this list is not complete. We're very interested in predictive models. They're relatively easy to encode, so we can do that pretty quickly. We're very interested in machine learning models and applying those. We're interested in calculators. We're interested in automated questionnaires. We're interested in tailored messaging capabilities. We're interested in applying disease models within our system, something that's rare today. Actually having the system understand something of the disease that's currently being progressed in terms of care, and so on. So all of these things and more are on our list. As I said, we've built a digital library platform for this type of knowledge. So this is the work that I'm doing to get a PhD in information science with a team of others. So we have software like this that allows us to store and manage digital knowledge objects. It gives us the capability to create and manage these online. All right, so this is something that over the last 15 months we built in Dr. Friedman's lab. Within the system, we build in all sorts of mechanisms, and we have a long way to go on this, that will allow us to ultimately, we believe, achieve this goal of knowledge fairness, making knowledge findable, accessible, interoperable, and reusable. So we know we need to link this knowledge in computable form to its original source. That's pretty obvious. Maybe also to the data. One thing that's very interesting, I think, to build trust in this type of knowledge is to start keeping records of who's using it and how they're using it, and what has been the impact. And so what Dr. Lee mentioned earlier, one of the ways that we'll know if the knowledge in a learning health system is effective is we'll put it to use, and if we're seeing benefits, and we can correlate those benefits with using the knowledge, well, we want to keep records of that. We want to let other people know that this knowledge seems to be improving care, which is the kind of data that you were also describing earlier for pharmacogenomics. All right, the 5 papers that give us the signal, right? So we believe that that will be very important. And then there's a lot that needs to be done in an IT and a technical way to protect these kind of resources so they don't get corrupted and so on. So there are things that we can do to protect them. All right, the fourth and final piece of the infrastructure that we're creating is not the library. It's a completely separate type of system which allows a person to take a digital knowledge object out of the library and actually use it, actually make it into a service that you can connect to existing health IT. And so this is what we've been working on here this week. We have a prototype of this. We've been running it on our PCs and on our laptops and even on a server at the Langfang Hospital here. So we deployed this locally this week and started testing it. We call this thing an activator. It takes the knowledge in this form and it actually puts it to use. Okay? So and then allows it to connect to any other system that you want to use. All right. So that is in a nutshell the knowledge grid. So the knowledge grid is essentially a technical set of methods, along with the people and the policy and the processes to deploy and use them. We take analytic results, we take knowledge in the world, we make it into a computer processable form. If it's actionable, we're particularly interested in it. We have a digital library within the system. We build in a whole host of mechanisms in order to build up trust and achieve our goal of knowledge fairness. Separate from the library, we have a thing called an activator that allows an organization or an individual to check out, if you will, like a book, check out a knowledge object out of the library and actually run it on your computer or some other system, and then ultimately connect through web service type mechanisms that you may be familiar with. APIs is the buzzword that we use for that. Connect through APIs to existing systems. So this is what we're creating, and we have a prototype that's working, and we're starting to think about a variety of test deployments to start using it in the world. So the international collaboration project, the current scope of the project that we have in mind, is to take the CPIC guidelines as we find them online, to encode them, to write the software code that represents that knowledge so the computer can process it with it automatically. So we want to build perhaps 40 or more knowledge objects that are drug and enzyme specific that encode that knowledge. We want to share those knowledge objects via a digital library. We want to apply these mechanisms within the system to make that findable, accessible, interoperable, and reusable. We want to deploy activators that will then run that code, and we want to connect that code to existing hospital systems both here and back in Ann Arbor and everywhere else ultimately if we can. So the work, the title of our project is a novel pharmacogenomic knowledge delivery mechanism for personalizing medication selection and dosing throughout Taiwan. And I want to thank the team at Langfang Hospital and at TMU, Taipei Medical University, for the great progress that we made rapidly this week. I came in on Sunday. We had 3 days of work. We started with alpha, library, and activator, and 2 knowledge objects. Today we have a public library, an improved activator, 4 objects. We have a new demo app, and we have a new authoring tool, all in about 3 days' time. That's pretty good. So I really appreciate that. We have next steps. So we want to complete this object collection We want to build out a library and deploy it here locally, and then we want to work together toward beginning to automate this process of keeping this knowledge up to date. All of these things are going on. So I think this is the last slide. And today, if you navigate on your computer to this URL, kgrid.med.umich.edu, that's the University of Michigan, library, you should find this screen. You should find 2 CPIC pharmacogenomic knowledge objects there with the code. They're publicly available. That means anyone can come along and take this code that we created this week and begin putting it to use. So this is just the very, very first early steps for national and international deployments of biomedical knowledge and pharmacogenomics and many, many other domains. And this is the work that we're doing. Thank you for your attention.